Hello fellow FEMAP users. Welcome to our annual update on what's new in SimCenter FEMAP. As the name implies, FEMAP is part of the Siemens SimCenter suite of solutions for simulation and test. More specifically, SimCenter FEMAP is part of the Mechanical Simulation Solution domain, which covers finite element-based solutions for structural, thermal, acoustics, and electromagnetics. SimCenter's Mechanical Simulation domain also includes a multi-body dynamic solution used for motion simulation of mechanisms, vehicle dynamics, and safety. As part of the Mechanical Simulation domain, SimCenter FEMAP helps you stay integrated with many of the other SimCenter applications available within this domain, such as SimCenter Nastran and SimCenter 3D. Overall, SimCenter FEMAP is a powerful and versatile FEA pre- and post-processor that offers robust modeling and meshing tools, interoperability with popular solvers, a user-friendly interface, customization and automation options, and strong industry adoption. Together, SimCenter mechanical simulation tools will help you more accurately model the behavior of your products, simulate faster, explore more design possibilities, and keep you integrated with the full design process. Our latest releases, SimCenter FEMAP 2301 and 2306, introduce key features that will help you streamline your meshing operations and analyze performance of rotating machinery with SimCenter Nastran. Now let me introduce you to Andy Haynes, who together with other members of the FEMAP team will lead you through highlights included in this release.
Thanks, Mark. For SimCenter FEMAP 2301, support for element addition and removal when using SimCenter Nastran's multi-set structural solution sequence, SOL 401, was implemented, which includes new simulation entities along with an analysis-specific option for boundary conditions and unique output vectors. The first thing that we're going to look at today is element addition and removal when using solution 401 in SimCenter Nastran. In order to create these entities or edit them, what you can do is you can come to Model, Simulation Entities, Element, Add, Remove. You can see that we already have one of these defined in here, but we're going to create a new one instead. You can see that we also have two options. We have ELAR or ELAR2. And we also have the type of value that can be used for element addition removal. So that can be time, inelastic strain, or mechanical strain. I'm just going to choose mechanical strain and enter a value. And then we have an option to choose whether we want to use a group or just select elements from the screen, which is what I'm going to do. Just going to do a nice little circle pick here to get my elements. And I'm just going to say OK. And when you're using the ELAR2, all the elements that you select are going to be using the same value. Now before moving on, what I'm going to do is I'm just going to edit an existing one that we have here. And this is in the ELAR2 style. And this is just elements across the top of the hole instead of kind of around the hole. And if I want to, I can show you how the time can be different for each selected element in our table. And if you want to see your elements and where they're going to be removed from, you can just pick all of these rows and then you can highlight them in the screen. When you go to make an analysis set, what you're going to do is you're going to want to come in here to boundary conditions and you're going to select which element addition removal entity that you want using this drop down. Once you've done that and you've run the analysis, then you can take a look at a contour plot and you can see everywhere where the elements have been removed for a particular step are no longer seen in the graphics window. And if I want to just go even a little bit further, I can show an animation where you will see how the elements are removed as the analysis progresses. Various meshing enhancements are now available in both FEMAP 2301 and 2306. For 2301, the Mesh Bodies command now recognizes mesh points, while the Mesh on Mesh command can now update line elements connected to shell elements being remeshed. In addition, a long-time meshing command, Mesh Region, has been made more powerful in 2306 by streamlining the selection of entities used to define the region. So the next thing we're going to talk about is the various meshing enhancements that were done for 2301 and 2306. For 2301, one of the things that we did was enhance the Mesh on Mesh command to be able to automatically resize line elements that are connected to shell elements. So I'm just going to change my method here to type, and I'm just going to choose my shell elements. Just going to say OK. And because we're doing a mesh on mesh, all the properties will stay the same. So let's say we wanted to refine the mesh, this whole mesh. We're just going to do divide by 2 here. Just going to say OK. And you're going to see I'm going to get a much finer mesh. But again, all my properties will be the same as they were with the original elements. And if I zoom in here, you can see that my line elements have also been updated. I'm just going to undo twice, and let's say we wanted to make your mesh a little coarser. What we can do instead is we can use mesh on mesh. Again, we can choose, just type, and it's going to choose all the shell elements in our model. And I'm just going to put in a value of 150 here. And again, everything is just going to be taken into account. And now you can see that our mesh has been made coarser instead of refined. Another thing that we did for 2301 was we added the ability for the body mesher, which is used by both the mesh bodies, and mesh on mesh commands, to be able to recognize mesh hard points, which are these red points on the model. So I'm just going to use our default mesh size, and you're just going to see after we're done meshing that everything has been, all of the nodes with the closest proximity to the mesh points have been moved to those mesh hard points. Finally, something we did for 2306 was we really enhanced the mesh region command, kind of a older command within FEMAP. So what we're going to do is we're just going to use mesh region, and I'm just going to select my one side of my region. Then I'm just going to select the other side, and in previous versions this was much more difficult because they had to be ordered sequentially, essentially numbered the correct way. Now what you can see is I can just say OK, can give it my number of nodes across that region, and you can see that it filled in those gaps, but it actually left a gap in the middle here. So what we can then do again is we can just use the same command. You can come in here, select the one side of my region, and then select the other side of my region. Say OK, enter a number of nodes between here, and you can see that I now have a fully connected mesh of some rather complicated geometry. For our next section, I'm going to ask Mary Kate Dugan, one of our FEMAP developers, to explain what we've been doing in the realm of rotor dynamics.
Thanks, Andy. FEMAP 2306 introduces extensive support for SimCenter Nastran's rotor dynamics solution sequence, Solution 414, which can be used to execute different analysis types, including maneuvers, normal modes, complex modes, harmonic response, and transient analysis of rotating structures. For rotor dynamics, 3 new element property types are supported. The first new supported element property type is the gear element, used for connecting rotors, and this property is written out to the gear card. The Fourier element couples a node on the 3D part of the model to a target node on the 2D Fourier axisymmetric portion of the model, writing to the FOU3 Nastran card. Rotor dynamics supports the Nastran pBear2 property type. Users can define bearings with constant stiffness, mass, and damping matrices, or stiffness, mass, and damping matrices with rotational speed, time, or frequency-dependent values. In addition to the new property types, there are 3 new entity types available for rotor dynamics. The model info tree has a new rotor dynamics branch that contains the new entity types: XY plot definition, bearing speed, and rotational speed. First, XY plot definition can be used to create an OutMGT entry, which allows users to generate nodal, elemental, and/or advanced XY plots for various types of rotor dynamics runs. These XY plots will appear as FEMAP functions, which can be plotted in the charting pane after results have been loaded. Next is bearing speed, which maps to the SPEBE2 entry and allows users to select the rotors SimCenter Nastran should use to retrieve the correct speed for bearing elements which are dependent on rotational speed. Finally, rotational speed is used to specify rotation speeds in three different forms: as individual rotation speeds, which writes an omega entry; as a linear sweep with equally spaced speeds, which writes omega 1, or as a logarithmic sweep, which writes omega 2. Rotor Dynamics Solution 414 has 5 new analysis types. Solution 414-101, Maneuvers, is a linear static analysis with rotational forces. Solution 114-103 is an eigenvalue analysis that computes modes of the system at rest. Solution 414-110 is a complex modal analysis that's used for finding critical speeds and analyzing the stability of the rotating system. Solution 414-111, a harmonic analysis for frequency-dependent excitation. And finally, Solution 414-129, transient analysis. In this example, we've performed a Solution 414-110 complex modal analysis. If we take a look inside of our options, we can see a new dialog box for writing the rotor D card. The user can specify the rotor speed variation type, either constant, linear by steps, or a function of our sweeping parameter. Then the user can specify up to 10 rotors by selecting their rotor regions. They can also apply a speed multiplier, either in the form of a function of the sweeping parameter or a constant value. The results data for rotor dynamics is stored to a file written in the HDF5 format, which is specific to Siemens products, the SCD5. For 2306, FEMAP is able to interact with the SCD5 file generated by Solution 414 to create both output sets and vectors, and also FEMAP functions to be used in post-processing. We can take a look at our functions and easily make a Campbell diagram. From the Campbell diagram, we can identify the critical speeds by looking at the intersection between the eigenfrequencies and the 2p line for a model that was evaluated in the rotating reference frame. Finally, we can perform some post-processing on the rotation speed at 12,000 RPM.
Thanks so much, Mary Kate, and I'm sure a lot of users are excited for rotor dynamics. Moving on, certain types of output are not always calculated by a particular solver. Thus, FEMAP 2301 allows creation of computed vectors either automatically when reading results or at any other time output is available in the model. Users can choose from a list of common output types, predefined envelopes or combinations, or reference an API script written to compute values required by their specific workflows. So what we're going to discuss now is the idea of computed vectors, which were added for FEMAP 2301. So I'm just going to come here to Model, Output, Computed Vectors. And you can see that I have two options: when to compute, automatically when results are read or created, or now in existing output sets. By default, this one, plate solid principles and invariance, is always going to be turned on to auto run when we're reading results or creating them via command like model output process. Or we can actually do now in existing output sets. So I'm actually just going to turn that on as well, and I'm going to turn on beam bar von Mises stress. But we have some other categories, including plate solid failure theory, laminate failure theory, and envelope results. I'm just going to say OK here, and I'm going to come to File, Import, Analysis Results. And I'm just going to choose my OPIP-P2 file. If I take a look at the output vectors I have, you can see that my principles and invariance have been calculated for my plate stresses, for my plate elements. If I come back in here to Model, Output, Computed Vectors, and I say that I want to do beam bar von Mises stress, which is going to calculate from the beam and bar vectors that were imported into my model, I can just say compute now. I can choose which output sets I want. And then I can just say OK. And now you can see that I now have beam bar von Mises stress, which I can take a look at. Okay. One more time, I'm going to come in here to model output, computed vectors, and I'm going to go to now in existing output sets, but I'm going to come to user defined, and you can see that we can create combinations, which are either linear combinations or RSS combinations, envelopes, where you just choose which vectors and which output sets you want to consider, or you can do an API script. I already have one specified here, so I'm just going to edit it, and you can just see that I'm choosing a particular .bas file, and I just have auto not specified for the ID range that it's going to create. What this is going to do is create an envelope, top-bottom von Mises stress with corners automatically. So I'm just going to say we're going to want to create this now, and just say compute now for that output set. And what we can then see is that we're going to have some user-defined vectors here at the bottom of our output set, which we can now take a look at. And if we zoom in, so what this did was it just created an envelope of all shell stresses, shell von Mises stress in the model, including the corner values. So you're basically getting a worst case scenario. Finally, to assist newer users locate functionality within FEMAP, a command finder, similar to ones found in other products, was made available in 2301, then augmented for 2306 to recognize words and phrases used by other CAE applications to guide users to equivalent FEMAP commands and tools. What we're going to talk about now is the command finder. So you can find the command finder in SimCenter FEMAP up in the upper right-hand corner. Essentially what you do, like in a lot of other products, is you just type a text string and then you click the little magnifying glass icon, and it's going to show you the commands and tools that can be used to do that type of thing. So if I just click size and I come here and click here, what it's going to do is it's going to show me some tools in the meshing toolbox and then some other FEMAP commands that mention the word size. So I'm just going to say mesh sizing in the meshing toolbox, and what you're going to see is this is going to bring it up and it's going to blink at me a few times to make sure I know which tool I'm taking a look at. Let's just say I wanted to do something a little different, and I typed the word grid, and grid is the word for node within Nastran. So if I type in grid and say, search for that, what you can now see is mesh locate, because it's locating nodes. So basically almost every command that has something to do with nodes will appear in this list, and if I just choose any of them, it's just basically going to automatically bring up the command. Something else that we can do is in some other CAE applications, the word equivalence actually is means the same as coincident to us. So if we type in something like equiv grid, what it's going to do is it's going to bring me up just that one command, which would be coincident nodes, which in this case our model actually needs in order to be fully complete. I can take a preview of my command, just say done. Also, if I just want some more help on the command at any time, I can hit F1, and it's just going to go out to the online help and show me everything about this command. And then I can just say OK to complete the command. One last thing would be something about geometry related, like surface. So if I just type surface, come in here, again, I can just see every command in FEMAP that has anything to do with creating or manipulating surfaces.
That was some great stuff, and thank you Andy and Mary Kate for demonstrating how SimCenter FEMAP can help our users be more productive and extend their analysis capabilities. Before closing, I want to remind everyone about the FEMAP community, where you can interact with other FEMAP users to discuss how to apply FEMAP and SimCenter Nastran for your applications. This community also includes knowledge-based articles posted by our support team and others that can provide insightful tips on using the software. For those of you out there that may not be FEMAP users today, please visit our website where you can download SimCenter FEMAP for free for 30 days. This will give you a first-hand experience on how FEMAP can help you speed your simulation process. This brings us to the end of our presentation, and thanks for taking the time to watch how SimCenter FEMAP makes real FEA easy.